Assalamualaikum warahmatullahi wabarakatuh. My name is Danish Daniel bin Amri Sham and my matric number is B0922100127. So today our group will present about pump in series and in parallel. Next, for the system pump can use in the industrial context, which we can see that the water supply system in high-rise buildings rely on parallel pumping configuration to deliver water efficiently across multiple floors. For the working principle, pumps in parallel share the same suction condition and discharge into a common outlet. They provide the same pressure head to contribute individual flow rates to increase total flow. We can see that the formula for total flow rate is Q total is equals to Q1 plus Q2 plus Qn, which Qn is the total number of Q, and then the head is H total is equals to H1 and H2. H total is equals to H1 equal to H2 equal to Hn.
Good evening. So my name is Muhammad Shukri bin Abdul Rasid. My metric number is B0922100091. So I will take a quick look at how pumps are used in a series and in parallel in building. So especially with a focus on a demand based activation and energy efficiency. So the first one is pump in parallel demand-based activation. So as we can see in many buildings, pump are installed parallel to handle varying water demands throughout the day. And the first one is during how demand, like at night, one pump may be enough. And the second is at demand increase, such as during the morning peak when many people are using water, so additional pump turn on automatically. For example, one pump might run overnight, while three could run during the morning rush. This setup ensures water is delivered efficiently without overusing energy. So the second one is pump in series pressure boosting. Pump in series are used when higher pressure is needed, such as in tall buildings. So water flows from one pump to the next, increasing pressure step by step to reach upper floor effectively. And the third is variable frequency drive, so VFD. To make this all even smarter, we use a variable frequency drive. So the VFD adjust motor speed based on demand. So they help maintain steady pressure and can make a more improved energy efficiency, so and reduce wear on equipment. This prevents pressure spikes and shortage, can make ensuring reliable water supply. I will continue the presentation, and I'm going to quickly go over the advantage and disadvantage of using pump in parallel, especially in a high-risk building system. So parallel pumps are common in high-risk system. So we can give an example in tall building. Parallel pumps are often used to meet a varying water demand efficiently. So for the advantage, first one is flexible flow control. Pump can be added or removed based on real-time demand. And second one is reliability. If one pump fails, others can keep the system running. The third is lower maintenance cost, since pumps uh, share the load. Each one runs less often. The last one is reduce wear, distributing work among pumps extends their lifespan. So for disadvantage, pump compatibility, all pumps must have a similar head flow HQ curve to avoid imbalance and performance issue. Second, complex control. The control system must coordinate multiple pumps efficiently. Third, higher initial cost. Installing multiple pumps increase upfront cost. So last one is more space required. More pumps means larger mechanical rooms, which can be challenging in high rise building. So the conclusion for this advantage and disadvantage are while parallel pumps are offer flexibility and reliability, they come with higher complexi- complexity and cost. So for choosing the right setup depends on the specific needs and scale of the building system. So that's all. Thank you.
Okay, my name is Xiao Bin. Okay, now I would like to present for the series pump. So the series pump is less common in building and more for extreme height. So what is the advantage? The first one is the series pump can increase the heat pressure. It's very useful for the tall building, especially for the building more than 80 floors. So, and for the system with extreme friction loss is very suitable. So for the second one, it is very useful when a single pump cannot meet the required pressure. So now go to this advantage. So the first one is it has a overpressure risk and may exceed pipe or fixture rating in lower zone. So for the second one, the series pump has no flow flexibility. So you can say it is energy inefficient due to all the pump must run even at low demands. So for the third one, it had more wear due to higher operating pressure. So for the last one is it face a maintenance challenge, which because it will shut down. When shut down, it will affect the entire system. Okay, next.
Assalamualaikum. My name is Amirul Aiman bin Muhammad Azani, and my matrix number is B0922109198. So today I will be present about the mechanical issue involved and state of the art. So we have three aspects we want to look, which is different pump in series and pump in parallel. So we go the first aspect, which is main purpose. In series, we want to increase the total head like a pressure, and in parallel, we want to increase the flow rate. For the second aspect is mechanical issue, flow imbalance. In series, we have less of concern, and in parallel, unequal flow distribution between pump. And then the last one is vibration or alignment. In series, critical in high pressure setup, and in parallel, vibration due to the hydraulic interference. Okay, next is state of the art, which is we use the recent technology to eliminate the error or any problem in the pump, like in series or in parallel. Okay, the first one we can use the magnetic coupling pump, which is we can eliminate mechanical seal, reduce leaking risk, and maintain it in high pressure application, especially in series setup. Okay, the second one we can use the smart piping system or IoT integration, which is in real-time monitoring for pressure, flow, temperature, and vibration. And also, we can predict maintenance through data analytics. And the last one is remote operation and fault detecting using SCADA system, which is the system more efficiently.
So for the last slide, I will present the VFD, which is variable frequency drive. So you can see here the big black box is called VFD. So it is used for running AC motor at variable speed so that it can give them a smooth startup. The work principle is it work by adjust the frequency to adjust the motor RPM. So you have a smooth startup lah. So the second one, so we can know it enhance energy efficiency and reduce the mechanical stress. Okay, that's all. Thank you.